Day two. Here's your warm-up. I'm not going to have the timer actually running. What I'll do is I will freeze the screen and eventually you'll see the timer. You'll hear me start talking. I'm going to try to set it up for 5 minutes. Do your warm-up. Go. All right, this is what I got. I'm rounding to the nearest tenth, so 1.9x plus 0.9. That's what I got. I'm sure it's right. I don't know. We'll see. What are we doing today? Some more scatter plot stuff. I will be able to characterize, analyze, and create scatter plots. Yay! All right, we're just gonna go through these as many as we can, as quickly as we can. Right off the bat, you have a scatter plot, wave height, and number of surfers. The table shows the heights in feet of the waves at a beach and the numbers of surfers at the beach. What I'm gonna do is I'm gonna let this guy right here be my x-axis, so we will say that the height is down there. We'll put surfers over here. We'll let that be my y-axis. Surfers. And the wave height, we can just go by ones, twos, threes. 1, 2, 3. The numbers are small and friendly enough that we could actually stop at 6 right there. What I'm going to do with the number of surfers is every other block I'm going to go by 10. So this would be 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. What do I have to do? 60, 50, 60, and 70. All right. Put your dots. 324 would be a point kind of like there. 661 would be a point right around there. 556 right around there, and 115. It almost seems like the higher the waves, the more people show up. Oh, look at that. Draw a line of best fit. Well, let's draw that line of best fit. There's my line. Right through the center. Yeah, I guess you could say that that is the positive correlation. What is the equation of the line of best fit? What I'm going to do is I'm going to take this information right here. I'm going to let the x values be my L1, my y values be the number of surfers. I'm going to pause the screen and let you use lin-reg for the equation for the line of best fit. All right, this is what I got. Rounding, of course. Y equals 10x plus 1.4. And I have to describe the relationship between the two data sets. Well, as height of waves increase as the height of waves increase, the number of surfers increase. Yeah. Yep. So that's that. Easy peasy. You're going to do this one on your own. Ready? Go. All right, how many days does it take to mow 30 lawns? Here's 30 lawns right there. It matches up with that point right there, which matches up with 4 days to mow 30 lawns. How many lawns can be mowed in one day? I don't know. That number is hovering in between 10 and 15. So we'll say 12-ish. If you said 13, if you said 11, not the end of the world. Describe the relationship shown in the data. Well, the more days worked, the more days you work, the more lawns you mow. It's positive correlation. Look at me running out of room. What does the slope mean? Well, the slope means is, you have lawns mowed per days worked. So a way that we could put that into a sentence is, well, slope means how many lawns you mowed over the course of time. So we'll say how many lawns mowed per day. What does the y-intercept mean? Y-intercept is that guy right there. So if you worked no days, the y-intercept means no lawns mowed. Yeah. Simple. Simple, simple, simple. So much fun too. Oh, well. What's this fun stuff? Outliers, gaps, and clusters? Well, an outlier is a dot that doesn't seem to fit anything. See how all these dots are kind of in the same area? This guy right here doesn't seem to belong. He's an outlier. Look at the second graph. See this chunk right here where you have a bunch of dots over towards the right in the middle, kind of scattered around. There's this chunk kind of clustered together. It's called a cluster. And look at this one on the right where you have all these dots, and then there's a space right here. I wonder what that gap is called. Well, it's called a gap. So, good job, everybody. I'm going to give you a minute to do the other ones. Go. Cluster. That's a gap. That's an outlier. Good job. Good job. Wonderful. 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 Describe the relationship between the data. Identify any outliers, capsule clusters. Well, let's take a look at the one on the left. You'll do the one on the right. There's a gap right there. And it looks like family size and laundry loads. This is a positive correlation, which means we can describe this by saying as family size increases, the amount of laundry increases. Makes sense. That's describing the relationship. Oh boy. We'll pretend that's a U. Laundry increases. You do the next one. All right. That's an outlier. And what do we have here? We have monitor size and price, probably talking about TVs or computer stuff. As the monitor size increases, the price increases. So that's what we'll say. As monitor size increases. Maybe the monitor we're talking about is a lizard. Because monitor is a type of lizard. See what happens? The price increases. Wow, good job, everybody. A super, super fantastic bang-up job. All right. You do this whole thing. Go. How many bushels were needed for 350 apples? Well, if that's 100, that's 200, that's 300, that would be 400, which means 350 lives right here. 350, beep, hits that dot, which goes over, beep, to 16. Eight bushels. Let me see. If that's 150 and that's 200, 8 bushels might be 175. If you said like 170, 180, you're in the right area. Describe the relationship shown by the data. Once again, positive correlation. The more apples, as apples increase, the amount of bushels increase. What does the slope mean? How many apples per bushel? Actually, it would be how many bushels filled per apple, but I don't like that. How many apples fit in a bushel? How many apples per bushel? And of course, the y-intercept lives right there in this red dot. No apples, no bushels. Of course, you could probably say a better sentence than that. Like, I don't know, the y-intercept means if you don't have any apples, you're not going to fill any bushels. Something along those lines. I'm being a little lazy. Shame on me. I'm doing this 3:30 on a Monday afternoon. Give me a break. All right, my wife just had a kid. Leave me alone. In the meantime, do that one on your own. How many yard sales are during the month of February? Well, February is the second month, and it looks like February is 0. But what about June? June is the 6th month. June seems to be 18-ish. So we'll say 18. During which months are there no yard sales? So 0 looks like 1, January, 2, February. November seems to have 1, 12, December. So we'll say January, February, December. What type of relationship does the data show? No correlation. Although we could say the warmer it gets, the more yard sales. So what type of climate might this neighborhood have? Kind of one like ours, like a cold winter, warm summer. One like ours. You know, you're not going to go outside in 30-degree weather and have a yard sale. That's crazy. Identify any gaps, clusters, outliers, whatever. There's a gap right there. So that's what I see. That's what I see. All right, boys and girls, last one. Line of best fit. This is going to be my L1 right here. This is going to be my L2 right here. You've done this plenty of times to know that this is Lynn Rag. Go. Okay, this is what I got. That's what I got. So what you're going to do is you're going to plug in 2013 into this equation. Tell you what, I'll give you a minute to do it. plugging in 2013 into that equation. The number I get is 14.76. Since these are in billions, I have to make sure that I say billion and throw that big old dollar sign in front of it, baby. All right, friends, that should do it for the day. If you need to rewind anything, you need to go back, please do. This is your homework for tonight. Work on that packet. Work on it. Work on it. That's a fun grand finale. Teacher, if you want to do the grand finale, go ahead. But you don't have to. I mean, it's no big deal. All right, remain blessed.